Today, I'm going to be giving a demo on how you could use Validere to prepare for 2025 Subpart W revisions. Now, in the Subpart W revisions in 2025, there's a lot of changes from flaring emissions factors to new emission sources. But the one that I want to highlight today is pneumatic devices and the updated bleed rates for high bleed, low bleed, and intermediate bleed pneumatic devices, as well as highlight how you can use measurement in your pneumatic bleed device quantification. So within Validere, I want to first start off by highlighting the dashboards. So as we prepare for the new Subpart W revisions, one of the things that we've done for our customers is create a projection of how your Subpart W emissions will change with pneumatics with the new bleed rates. So here we can see over time our emissions, assuming 24/7 for pneumatic devices and how it's going to change. Here we can see that our low bleed pneumatic devices, the bleed rate is going up. So you can see that it takes a much larger portion of our emissions now. But in net, the decrease in bleed rates for our intermediate bleed and our high bleed have gone down. So what this means is that in this example here is that if we do nothing, we could see that our WEC savings is going to, we're going to save an additional $259,000, assuming we do nothing just by adopting the new emissions factors based on the makeup of our high, low, and intermediate bleed. Now this is going to vary customer by customer based on the count of high versus intermediate versus low. And one of the things that you might look at is incorporating measurement to come up with measurement informed bleed rates. Another thing to add here in this dashboard is that there is a simple toy model down below for you to evaluate how your WEC savings would change if you've done some pneumatic device removals. If I've removed 100 or 50 high bleed pneumatic devices, what are the additional savings I could expect for my waste emission charges? And this is just assuming a methane fee of $900 per ton. So this is an example of how you could use Validere to forecast forward how my emissions are going to change with the revised emissions factors. Similar analysis could be done for our flare stacks as an example. Now, in the Subpart W revisions, it also states that we could use measurement to come up with our own bleed rate. So to highlight how this would be handled, I have a asset with an emission source here, pneumatic controller, and on this pneumatic controller, I have an estimation method, which is the quantification method that I'm going to be using for quantifying the emissions of this pneumatic controller. And if I click into this here, I can see the formula that has been implemented from the US Part 98 Subpart W. We're using the natural gas pneumatic device calculation. Now I'm going to skip to this results tab, and here on this results tab you can see here that we're assuming 24/7, we're assuming a consistent gas composition, but the thing that I want to highlight here is that the emissions factor changes month over month. And this is to demonstrate how you could use a meter to measure the bleed rate of a pneumatic controller as allowed in the Subpart W revisions. So here, if I click in May of 2024, we can see here that we have an emissions factor of 6.568 scuffs per hour, which is different than the default that is set for intermediate bleeds. And the reason why it's different is because we're taking this directly from a measurement device that is measuring the bleed rate continuously. So clicking on this hyperlink, I can see here that it's a record of 6.568 scuffs per hour, and it's coming from this meter. And then I can zoom into this meter to see exactly what the measurements were during that period of time. So here we're ingesting the continuous measurements from this flow meter, and then we're taking the average of the monthly flow meters and using that as our bleed rate for that emissions factor. Now, this is just an example of how you could use a meter to measure your bleed rate of pneumatic devices, but I would like to think about all of the other scenarios where we would like to incorporate continuous measurement for the purpose of quantification for other scenarios, such as flare stacks where we have a flare meter.